people say glass half empty, they usually mean a glass containing equal parts water and air. But what if the empty half of the glass were actually empty? A vacuum. The vacuum would definitely not last long. But exactly what happens? For our scenario, we'll imagine 3 different half-empty glasses. The traditional air-water glass, a vacuum on top glass, and a vacuum on bottom glass. The first handful of microseconds, nothing happens. On this timescale, even the air molecules are nearly stationary. For the most part, air molecules jiggle around at speeds of a few hundred meters per second. The vacuum on the right is surrounded by barriers, so the air molecules can't easily get in. The water, being liquid, doesn't expand to fill the vacuum in the same way that air does. However, in a vacuum, it does start to boil, slowly shedding water vapor into the empty space. The water on the surface of the left glass also starts to boil, but the incoming air will stop it before it really gets going. After a few hundred microseconds, the air rushing into the glass on the left fills the vacuum completely and rams into the surface of the water, sending a pressure wave through the liquid. Around this time, the glass on the right starts to visibly lift into the air. The air pressure around the glass is trying to squeeze the glass and water together. The glass on the right, air pressure pushes the glass up from below unopposed with 100 pounds of force while simultaneously pushing the water down from above. This is the force we think of as suction. The glass and the water are moving too fast for the vapor buildup to matter. Less than 10 milliseconds after the clock started, they're flying toward each other at several meters per second. Without a cushion of air between them, just a few wisps of water vapor, the water smacks into the bottom of the glass like a hammer. The momentary force on the glass is immense, and it breaks.